Today starts the first day of our new unit on inequalities. And if we look at the title of today's notes, we are specifically going to focus on inequality skills, the refresher side of life. So bringing back all of our ninth grade inequalities knowledge. So my goal is that as we work through this, you feel that you're more and more comfortable and you're remembering what we did or what you guys did last year. So the first four questions are a warm-up for solving because there's a strong connection between solving equations and solving inequalities. We're going to draw lines on our equal signs always to keep the two sides of the equation separate. We're trying to solve for x. To do that, we will add 4 to both sides first. Draw our line all the way across. Good habits, please. Bring down 6x. We have 6x equals 17 plus 4 is 21. We will now divide both sides by 6, show dividing both sides by 6. Now, 21 is not divisible by 6, but we can reduce this fraction. 21 and 6 are both divisible by 3. So our final answer is x equals 7 divided by 2, or 7/2. Number 2, line down the equal sign. Pay attention to where x is. I see x is on the right, so I'm going to focus my attention here. Trying to get x to be by itself, and we always want to ask ourselves, is there something we could add or subtract first? And the answer is yes. I can take care of that 19. The opposite of a positive 19 is a negative 19. So we will subtract 19 from both sides, line all the way across. 19 is gone. 19 minus 19 is 0. 23 minus 19 is 4. So 4 equals negative x. And the question is, are we done? We are not because of this negative. So to take care of that, we'll divide both sides by negative 1. That's what that negative sign means. There's a negative 1 right there. So we get x equals negative 4. From this point forward, if I do a question and I get it started and you feel confident that you can finish it, I'd ask that you hit the space bar to pause the video, you try it, and then see if your answer matches with mine. Number 3, I'll draw lines on the equal sign. I see a 5 outside these parentheses. We will distribute 5. 5 times x is 5x. And then 5 times a negative 3 minus 15 equals 15. So here's a perfect example. If you can finish it, hit the space bar, finish, and then check your answer with mine. I will add 15 to both sides. That gets us 5x equals 30. Divide both sides by 5. X equals 6. Number 4, line down the equal sign. And this is where it starts to get very important because I see a lot of people try to combine like terms. They try to combine 2x and a negative 4x, and they tell me that's negative 2x. That is wrong because it means you were combining like terms across the equal sign on each side of the equation, and you cannot do that. To move across this line, we have to use addition or subtraction. So keep in mind the goal of x equals a number. Standard practice is to gather all of the x terms to the left side and numbers to the right. So if I pay attention to this side first, I just want terms that have x. So this positive 7 has to go. I will subtract 7 from both sides to make that happen. Notice I wrote my minus 7 under the negative 11 because that's like terms. It would not make sense to write it underneath the negative 4x because I can't do that. So I have 2x equals negative 4x minus 18. If you can finish it from here, pause. On the right side, I just want numbers. So this 4x, this negative 4x has to go. So I'll add 4x to both sides. Line across. So I have 6x equals, this is gone because it's 0. And to wrap this up, we'll divide by 6, divide by 6, Let me move this goal out of the way. So I get x equals -3. Now that our brains are warmed up with how we solve, let's make sure we're good with some very basic inequalities and inequality notation. Do we remember? Write the inequality for the graph shown. So we're going to use x as our variable. This would be x is less than 1 because I'm shading to the left. That's towards -infinity, towards negative values. X is less than 1. And there's no or equal to because this is an open circle. Number 6, what do you think 6 will be? Pause, try it, and then check. I get x is greater than or equal to -3. Greater than because it's shading to the right, so bigger than -3, and I have the or equal to part because it's a solid dot. We have a quick practice here with vocabulary and language. The directions are to write an inequality to represent each real-world scenario and graph. So we're going to graph it and we're going to write it. To serve as President of the United States, you must be at least 35 years old. So I know I'm going to have a circle on 35. Now I ask myself, is it open or closed? Well, you have to be at least 35. So if you're 35, you're good. So this is going to be a solid dot, and 35 is the minimum. You have to be at least this old. So I will shade to the right. As an inequality, this would be x is greater than or equal to 35. Number 8, to compete in the Junior Olympics, you must be under 17 years of age. I don't see 17 here, but here's 15, here's 20, so I know 17 will be approximately right there. You have to be under 17. So ask yourself, if you're 17, can you compete? The answer is no. This is going to be an open circle. Under 17 means shade to the left, and technically, you can't be negative years old, so it's actually going to have a stop right there at 0. And anything in between, according to this, is good. It wouldn't make sense if you're a year old, you're not competing, but technically this scenario didn't tell me like between 12 and 17. So we're just going to put a real world end to it right there. If you're struggling to understand why it's an open circle and less than, you can change the sentence to deal with money, for example. So to use a coupon, you must spend under $17. So if you spend 17, you can't use it. It has to be under that much. You'll find me connecting this to real-world scenarios to money a lot because it helps make sense of the situation. As an inequality, I would just be fine with this. We added the real-world end to it, but in terms of the language, I'd be fine with x is less than 17. Technically, what's graphed here would be x is less than 17 and greater than or equal to 0. But this idea of x being in between two values will come up later in our unit. For Thanksgiving dinner, we will need a turkey weighing more than 20 pounds. Open circle on 20, shade to the right. It has to be more than 20. 20 itself is not heavy enough. More than 20. X greater than 20. Again, if you think of money, to use a coupon, you have to spend more than $20. If you only spend 20, can't use the coupon. It has to be more than 20. Open circle on 20, shade right. At the amusement park, only children less than 48 inches tall may use the kiddie cars. So 48 is approximately right there. You have to be less than 48. So it's open on 48, shade left. We have a real world end at 0 because we can't have negative height. At this point, if I asked you to write this, I would accept two answers. I would accept x is strictly less than 48 as one answer. Technically, what we drew here, or what we graphed, is x is less than 48, and bigger, greater than or equal to 0. Either of these I would take though, okay? This is not the focus of today's lesson. This is just trying to help warm our brains up with inequality language, making connections to inequalities that we come across every day in real life. Let's get into our solving. This is really the focus of today, is refreshing our knowledge of solving. Again, as soon as I start one, if all you needed help with was starting and you can finish, pause, you finish, and then check answers with me. I will be drawing lines down the inequality signs just like I would if it was an equal sign, and I will keep my inequality signs on this line. Pay attention to where x is. I see x right here. On this side of the equation, ask yourself, is there something you could add or subtract first? The answer is yes. I can take care of this minus 9 by adding 9 to both sides. Now I have x divided by 2 is less than 6. How do we undo dividing by 2? What's the opposite? What's the inverse operation of dividing by 2? Multiplying by 2. So I will multiply both sides by 2. Notice how I use parentheses to show that. Dividing by 2 and multiplying by 2 are opposite operations, so those 2's cancel out, and I have x is less than 12. Notice how careful I was to keep this inequality from step to step. If you drop it, it's going to sometimes be very difficult to work your way back, so keep it with each step. Let's get some numbers here, 10, 11, 12, 13, just a couple is fine. Open or closed on 12. Based on this inequality, I see it's a strictly less than, so it's going to be open on 12, left or right. Less than is left. And I'm done with that graph. 12, let's draw a line down the inequality sign. X is on the left side of the equation, so I pay attention, X is on the left side of this inequality, so I pay attention to the left side. There is something I could add or subtract first. We can deal with this 10 by subtracting 10 from both sides. Negative x greater than, that negative still here, negative x. Bring down the inequality sign, greater than. 5 minus 10 is negative 5. To finish this up, this negative represents a negative 1, so I will divide both sides by negative 1. Who remembers what happens to the inequality sign when we divide by a negative? I hope everybody is saying, Mr. A, it flips, the inequality sign flips, and I agree with you. So this becomes x is less than positive 5, and we're done. Let's get some numbers here. So 3, 4, 5, 6, 7. That's good enough. Open or closed on 5. Open. Open circle, left or right. Less than 5 will be left. (13) Line down the inequality sign. Where is x? X is on the right side of this inequality, so I'm actually going to now pay attention to over here. Let's ask ourselves, is there something we could add or subtract first? The answer is yes, we can add 5 to both sides, so we'll do that first. 19 plus 5 is 24. The inequality sign is still less than or equal to, and then I have a 6x. Again, still paying attention to this right side because that's where x is. I will now divide both sides by 6. 24 divided by 6 is 4. This is less than or equal to, and I have x. Now, when I read this out loud, 4 is less than or equal to x, kind of sounds strange because typically we always have the variable that coming first. So we will actually rearrange. I want x to come over here and this 4 to come over here. Now, when I do this, I want you to imagine that this side of the inequality is like glued to the x. So when x comes over here, this side of the inequality, it's going to follow. So this becomes x is greater than or equal to 4. That came from rearranging. And I'm going to be very careful to make sure I use that word rearrange and not flip, because we typically say flip the inequality sign flips when we divide by a negative. This is flip. It went from being greater than to less than because we divided by a negative. Here, these mean the same thing. Like if I read this starting at x, this says x greater than or equal to 4. This says x greater than or equal to 4. They mean the same. We just rearranged so that the inequality comes first. Let's get some numbers on our number line. 3, 4, 5, 6, 7 is good. Open or closed on 4. Closed on 4 because of that or equal to, and now left or right. Well, it says greater than, so greater is to the right. And we're done. 14, line down the inequality sign. Where is x? I see x on the left side of the inequality. This is what I'll pay attention to. Is there something we could add or subtract? Yes, this positive 9. So we will subtract 9 from both sides. 9 minus 9 is 0. That's gone. I'm left with negative 2x on the left side, greater than 15 minus 9, which is 6. To finish this, we'll divide by negative 2, divide by negative 2. Dividing by a negative, the inequality sign flips. So this becomes x is less than negative 3. Let's get some numbers on the number line. Negative 5, negative 4, negative 3, negative 2, negative 1, 0. Open or closed on negative 3. Strictly less than, so open, I don't see any or equal to, and then less than is left. And we're done. 15, line down the inequality sign. If you're good to try this one on your own, press pause, compare with me when you're done. I will be paying attention to the right side of the equation because that's where I see x. I ask myself, is there something I could add or subtract first? The answer is yes. We can add 13 to both sides. Line across. Negative 3 plus 13 is 10. Less than or equal to. Negative 2x is still there. These 13s, negative 13 and a positive 13 is 0, so those cross out. Now we will do what? Well, I see negative 2 times x, so I will divide both sides by negative 2. This becomes a negative 5. The inequality sign flips because we divided by a negative. So here's my answer. But again, we don't like having the number on this side. We like having the variable. So now we will rearrange. I want x to come over here, and I want this number to come over here. Visually imagine this side of the inequality gets dragged over here with x. So that becomes x is less than or equal to negative 5 because we rearranged it. If I read from the variable, this says x less than or equal to negative 5. X less than or equal to negative 5. These mean the same thing. Let's get some numbers on the number line. Negative 7, negative 6, negative 5, negative 4, negative 3. A couple is fine. Open or closed on negative 5. Closed, because this is or equal to, and now left or right. Less than is to the left. We're done. Number 12, or excuse me, number 16. Let's get a line down the inequality sign. Now I have variables on both sides. So I just noticed, I'm not sure why my numbering is off. Mine says 16, but I think yours says 12. Either way, just try to pay attention to what the question says and not the number. I apologize. I'll fix those numbers. So this is not 16, it's 12. And if you want backtrack, cross off 15. I think that's your number 11. Sorry about that, guys. But anyway, getting back to the math. So I have negative x minus 3 greater than or equal to negative 10x minus 12. Variables on both sides. Just like before, we have a goal of x on the left and then numbers on the right. So if I only want x terms on the left, this minus 3, no good. Let's add it to both sides. So negative x greater than or equal to negative 10x. And then negative 12 plus 3 is a negative 9. On this side, I just want numbers, so this negative 10x can't stay. We'll add 10x to both sides. Negative x plus 10x is a 9x greater than or equal to negative 9. That's gone. And we're super close to being done. My last step would be to divide by 9. Divide by 9. X is greater than or equal to negative 1. I'll actually write that off to the side. Notice we did not flip the inequality sign because we did not divide by a negative. The fact that 9 is negative doesn't matter. It's only if you actually divide or multiply by a negative that the inequality will change. Let's get some numbers. Negative 3, negative 2, negative 1, 0, 1, 2. Open or closed on negative 1. This will be closed. Left or right? Greater than is to the right. And that's all set. This is 13. Let's get a line down our inequality sign. What are we going to do first? Let's leave 4x plus 8 alone for a second, less than or equal to. Sending in the 2, distribute 2. This would become, what would it become? 2x minus 12. Pause here, please, and finish. Notice that you have x's on both sides. You have to gather your x's to the left, numbers to the right. Pause, try it yourself, and then we can compare answers. I just want x's on the left, so I will subtract 8 over. Your first step might have been different. That's okay. Maybe you dealt with this 2x. I'm going to do that next. On the right side, I just want numbers. So this negative 20 can't stay. I'll subtract, I just want numbers. So the negative 20 will stay. It's the 2x that can't stay. So I'll subtract 2x from both sides. 4x minus 2x is 2x, less than or equal to negative 20. Divide by 2. Divide by 2. X is less than or equal to negative 10. Let's get some numbers on the number line. Negative 12, negative 11, negative 10, negative 9, negative 8. Open or closed on negative 10. I have an or equal to, so it's closed. Left or right? Less than is left. This is 14. So I think what happened was I printed this to Smart Notebook, but it was a longer version, and then I cut it down, and I forgot to change the numbers. Sorry about that. So we have negative, and then x plus 7 inside parentheses, and then an 8x minus 25. Let's distribute in the negative. That would become negative x minus 7, still greater than symbol, and then 8x minus 25. Pause, please. Finish on your own. I choose to add 7 first to both sides because I just want variables, so this 7 can't stay. So negative x greater than 8x. Negative 25 plus 7, I got negative 18. On this side, I just want numbers, so this 8x can't stay. I'll subtract that over to the other side. Negative x minus 8x gets me negative 9x greater than, that's gone, negative 18. To finish this up, I'll divide both sides by -9. I get x less than 2. The inequality sign flipped because we divided by a negative. Notice how careful I was to keep track of the inequality sign from step to step. It really helps to not drop it by accident. So let's get some numbers on the number line. 0, 1, 2, 3, 4. Open or closed on 2. It will be open, and less than is left. This is 15. Let's draw a line down our inequality sign. Something should catch our attention on the left side. Do you see it? On this left side, I do have like terms. I have a -5 and a -25. Those are like terms. So -5 plus -25, I can combine and get what? What's -5 and -25? That makes -30. The plus 7x is still there, and I still have less than 19. Pause, finish from here. I'm going to add 30 to both sides. So I have 7x is less than 49. And now I will divide by 7, and I got x is less than 7. Get some numbers, 6, 7, 8, 9. Open or closed on 7. It'll be open, this is strictly less than, and then less than 7 will be to the left. Number 20, line down the inequality sign. Take a second to examine both sides. We're getting into some more involved questions, which is awesome. We really want to make sure we don't miss something we could do. On the left side, do you see like terms? I do. I see a -6x and a +5x. I can combine those, so this becomes -7, that stays. What is -6x plus 5x? That is a -x. This right side stays the same. Pause, finish from here. If I just want variables on the left side, this -7, I will move first. (13 plus 7 is 20, and I bring down the +3x. On the right side, I just want I just want numbers, so this variable can't stay. So I'll subtract that over. -3x minus 3x. That gets me -4x less than 20. This is gone. I've reached my goal. I just have variable terms on the left and a number term on the right. Now when I look, the last thing that needs to happen is divide both sides by -4. So I get x is greater than -5. Get some numbers on the number line. Open or closed on -5. That will be open on -5, and then ask yourself left or right. Well, greater than is to the right. That was 16. Okay, real world. 2 real world examples that will help you on your homework. This is supposed to be 17. This is supposed to be 18. And because it's going to drive me crazy, if you guys could make sure that our answers line up, I just want to make sure my other ones are right. And they're not. This is supposed to be 7. This is 8. 9, 10, 11, 12. Okay, so this page should have 7 through 12. This page has 13 through 16. And now we're doing 17, 18. Whew, okay. Stephen has $500 in a savings account at the beginning of the summer. She, I guess Stephen is a girl's name now, wants to have at least $200 in the account by the end of the summer. She withdraws $25 each week for food, clothes, and movie tickets. How many weeks can she take money out and still have what she wants? And what she wants is to have $200 left. Defining the variables, we'll look for keywords like per, each, and every. So I see each week. That tells me X will be number of weeks. We should be experts at looking for per, each, and every. So let's see if we can identify key pieces of information. 500 in the savings account at the beginning of the summer. That's what they're starting with. So if that's what we're starting with, 500 is what you start with. What happens to that 500? Well, when I look, it says that we're withdrawing $25 each week. Withdrawing is adding or subtracting. That is subtracting $25 per week. She wants to have at least 200 in the account. At least 200 in the account would be greater than or equal to 200. So this is greater than or equal to 200. Start with 500 in the account, withdrawing $25 per week, and wants to have at least 200 in the account. There's our inequality. Now we can solve. So I'll rewrite it. 500 minus 25x greater than or equal to 200. Let's solve. We'll subtract 500 from both sides. From here, go ahead and pause, finish, and see what you get. So we have negative 25x greater than or equal to negative 300. Divide by negative 25, divide by negative 25. X is less than or equal to 12. X is weeks. So this is X is less than or equal to 12 weeks. We're going to write a sentence in a second, but the sooner we get a label on there, the better. Let's graph 10, 11, 12, 13, 14. Open or closed on 12? Open. Left or right? Less than, did I just say open? It's closed, excuse me, or equal to is closed. And then less than would be to the left. A sentence. The sentence is key. It tells me you understand what the answer means. Stephen is a girl with the coolest girl name ever. Stephen can withdraw or take out money for how much time? What does this mean? Less than or equal to 12. Well, it means it can withdraw or take out money for up to 12 weeks. And have at least 200 in the account. So up to 12 weeks, which means 2 weeks, 3 weeks, 4 weeks, 5, 6, 7, 8, 9, 10, 11 weeks, 12 weeks, all of that is possible. Up to 12 weeks, she can take out the $25 every week and be okay. So now we don't just have a number that's an answer. We have a range of numbers. We have multiple correct answers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are all answers to this situation. Up to 12. Okay. Let's look at 18. Keisha runs Style and Hair Salon. She charges a $1.75 flat rate to braid hair in addition to 65 cents per braid. We know that that's going to be important, so let's circle that. Maria has a special event to go to, but is on a budget and can spend no more than $10. How many braids can she get? Well, I already identified per braid, so I know X will be number of braids. See if you can build this inequality on your own, and then we'll compare. Charges a $1.75 flat rate to braid and 65 cents per braid. That becomes 175 X. No. Back it up. $1.75 flat plus 65 cents per braid. So 0.65X. No more than $10. You can spend no more than that. That is your limit. You can spend no more than that. That would be less than or equal to 10. Less than or equal to 10. We have the inequality. Now we can solve. So I'll rewrite it. 175 plus 0.65x less than or equal to 10. Line down the inequality. Go ahead and solve. Pause here, solve it yourself. We'll compare. See if you can finish solving the graph and the sentence. I'm going to subtract 175 from both sides. So I get 0.65x less than or equal to 10 minus 1.75 is 8.25. I'll divide both sides by 0.65. X is less than or equal to 12.69. Now, this is the math answer. The real world answer would be X is less than or equal to, interesting question. So technically, remember, this represents braids. So what do you actually have the money for? Well, nobody gets 0.69 of a braid. So we need to actually round this down to 12. If you don't have enough to make 13, then all you're going to get is 12. Let's get some numbers. 10, 11, 12, 13, 14. Open or closed on 12. It will be closed because it's or equal to and less than. Hey, kind of cool. Both these answers came out to be 12. Total coincidence. Getting a sentence. Keisha can afford, there's many ways to say this, up to 12, 12 or less, however you want to say it. Up to 12 braids. So really what that means is 0 to 12 is the possible answers, right? Up to 12. Or you could say no more than 12. So again, we don't just have one right answer anymore. We have multiple right answers. None, which doesn't make sense. I mean, 0 wouldn't make sense because she walks in and walks out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Any one of those numbers is acceptable for her money. Up to $10 is what she can spend. And we're done. So use these to help you with your real world part of the practice, which should go well, and it'll be great. Remember that tomorrow we will have a 1-question notes quiz. And that's all I've got for you. So send me any questions on Remind, and I will see you tomorrow. Bye.